Now let's talk about Kirchhoff's laws and different spectrums. When we discussed spectrum of wavelengths with different energies, we saw all colors. So this full color, like a rainbow picture, is continuous spectrum. In this scenario, basically we have a hot solid object, and this object can emit all energies. And if you put something, a diffraction plate or a prism, in between, we can see all of these colors. So this is visual picture. But in our measurement, we are measuring intensity. So for intensity, for different wavelengths, for different colors, we see this plot. This is intensity. But there are other types. Now let's say instead of this hot light source, we have a hot diffuse gas. And what we see in this case for hot diffuse gas is few lines, not all colors, just few of them. And if we use intensity plot, we see something like this: nothing, sudden change, high intensity, nothing high intensity, nothing high intensity, and so on. So it looks like there is nothing, and suddenly we have emission of one specific color or one specific light. This is emission spectrum. On the other hand, if we change this configuration, let's say we have our hot light source again, but there is a diffuse cold gas. And in this case, what we see is something like this. We see full color spectrum. However, there are missing lines. And if we plot intensity, we see this spectrum, but one line is missing, another line is missing, and so on. So it looks like something is absorbed the light in between. This is called absorption spectrum. Why we see these lines. So it has something to do with the atomic structure. For atomic structure, we have nucleus at the center and different energy levels. Electrons are moving in different levels. Now let's flatten this picture. Let's look at here. So these are levels, but instead of circle, we are using lines to show these levels. And here we see their energy levels. So we say this is 0, this is 10.2, this is 12.1 electron volt, and so on and so forth. So just energy unit. 0 is our ground level. What's happening and what's important for atomic structure is that we have a specific energy difference between two levels. Let's say this level and this level, level 1 and level 2. The energy difference is 10.2. So what it means, if we have electron here moving in level 1, and if we give 5 electron volt, this 5 electron volt is not enough to jump from 0 to 10.2. And anything in between is impossible. So if we give 5 electron volt to this system moving in this level, there will be no change. This 5 electron volt will move around without any problem. It's the same for higher energy. Let's say we have 11 electron volt. So 11 electron volt means moving from here to somewhere around here, because it's more than 10.2. This is also forbidden. It's impossible. So there will be no change for 11 electron volt. But if we have exactly 10.2 electron volt, this electron will take that energy and will jump to this level. So this specific energy will be missing. And this is what we see. We see, for example, there is no change for this photon, there is no change for the next photon, there is no change for the next photon until we get to this point and we have this specific energy, then we see sudden absorption. But why we see different lines? Because there are different levels. We have 10.2 here, we have 0.7 electron volt here, we have 1.9 electron volt here, we have 2.6 electron volt here. So these are different possible movements from one level to another level. And because they are moving from lower energy to higher energy, they need extra energy. And they will absorb this energy from their environment, from moving photons. That's why it's called absorption spectrum. We can have emission spectrum. It's the same thing. But for emission spectrum, electrons are in higher level. They jump to lower level. And again, because of this conservation of energy, they have to do something with this extra energy. They have to get rid of this extra energy. So they will emit photons. So you will see there's nothing, but there's a specific line, a specific energy we see in this spectrum. And because they are emitting this light, this is called emission spectrum. And these are like fingerprints.